Here we have some examples of two-step equations. The equations we are used to solve mentally are called one-step because they only include one operation. So you know that the inverse operation of multiplication is division, the inverse of division is multiplication, the inverse of addition is subtraction, and the inverse of subtraction is addition. So here we're going to use inverse operations. You know that the order of operation is going from multiplication to subtraction in this order: multiplication, division, addition, subtraction. In order to solve equations, we have to use the inverse order. So first of all, we do undo, subtraction, then addition. If it depends actually on the example, then division, and finally multiplication. So if we go straight to the point, the first equation has two operations. Here we have multiplication and addition. So 3 times a secret number plus 4 equals 10. So maybe we can use mental math and find out what the number is. But more than that, we can use inverse operations in order to solve these equations. So here first we have that this operation is addition. The inverse of addition is subtraction. So I'm going to subtract both sides 4. So here I have a 0 pair. This is 0. And then 3x will remain. 10 minus 4 is 6. And now I have to isolate the variable. Since this operation is multiplication by 3, I have to undo it. Dividing both sides by 3. So I know this is 1. So x equals, and 6 divided 3 is 2. Now if you substitute this 2 in the original equation, you will see that it checks, and that's equal. So 2 times 3, 6, plus 4 equals 10. So maybe that agrees with your mental math before trying to solve that equation. In this case, we have two operations as well. One is division and the other is addition. So following that order, we have to undo addition first before division, right? So here I'm going to subtract both sides 3, so I'm going to isolate the variable. I know that this is a 0 pair. Now w fourths equals 1. But I need to get the value of w. I need to know exactly how much w is. So I'm dividing w by 4. The inverse operation of division by 4 is multiplication by 4. But remember to do it both sides, so the equality remains. Here again I have 1. So I have finally that w is 1 times 4, or 4. Now same process. If you substitute this one in the original equation, you have that 4 divided 4 is 1 plus 3 equals 4. So the equation checks. In this case, we have the combination of multiplication and subtraction. So let's undo first subtraction and then multiplication according to that order. So I'm going to add both sides 1. And again, I'm going to have here a 0. Then I will have 2p equals 19 plus 1 is 20. And then to undo multiplication by 2, I divide by 2 both sides. Remember to keep the equation, to keep the equality. So 2 divided 2 is 1, and now I have that p equals 20 divided 2 is 10. Again, like just with the other two examples, if I substitute this value for p, 10, 2 times 10 is 20, minus 1, 19. So the equation checks. And finally, with this example, we have the combination of division and subtraction. So first, I have to undo subtraction by adding 2 on both sides to keep the equality. These operations are based actually on the properties of equality. Whatever you do on one side has to be done on the other side. So here I have a 0. Now we'll have m thirds equals to negative 5 plus 2 is negative 3. And now I have to undo division by 3. So multiplying by 3 both sides. Remember, whenever you see something like this, I'm multiplying. So if you want to avoid confusion here, so I know this is 1. So m equals negative 9. Since I'm multiplying two numbers with different signs, the result is negative. So now if I want to substitute here, negative 9 divided 3, negative 3 minus 2 equals negative 5. which checks the equation and makes it true, just like in the other cases.